and multiples. So let's see the difference between a factor and a multiple. So let's say that I ask you for the factors of the number 4, for example. All what I'm asking you is, what are the numbers that you can divide 4 and have a whole number? So for example, if you divide 4 by 1, that's 4. So then 1 is a factor. If I divide 4 by 2, that's 2. That means that 2 is a factor. If I divide 4 by 3, I don't get a whole number, so 3 is not a factor. Now if I do 4 divided by 4, then I get 1, and then 4 is a factor. Now 4 has the following factors: 1, 2, and 4. If I were to ask you what are the multiples of 4, that's a little bit different. All what you have to do if they ask you for the multiples, so if I tell you like, oh, can you give me the multiples of 4? You'll have to do 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on and so on. Basically multiply 4 by 1, by 2, by 3, and so on. Now, let's say that I have like, a higher number, because you might be asked to find the factors, for example, of the number, let's just here put 75. So they're going to ask you, hey, can you please find the factors of the number 75? Now, you can check, like you can actually start like 1, 2, 3, 4, 5, but this is going to take forever. So the best way to figure out the factors of 75 is to do prime factorization. The first thing that I want you to do is divide 75 by 5, because we know that 75 is divisible. So look, 75 is divisible by 3, because 12 is a multiple of 3, or is divisible by 3, and also 75 ends with 5, therefore is also divisible by 5. So 75, I can write it down as 5 times 15. Now I'm going to continue breaking down the 15, and 15 is 5 times 3. So look, now I have the prime factorization of 75, which is going to be 5 squared times 3. From here, it's very easy to find now the factors, because the factors are going to be the possible combinations of all of these numbers. So for example, the first one is always going to be 1. The second factor is 5. Then I look at this and I say, well, what about 5 times 3? That's 15. Then I say, well, what about 5 times 5? Notice that I'm doing basically like the possible combinations between two factors. So that's going to be equals to 25. And finally, I look at this and I say, well, the last factor is going to be 5 times 5 times 3, and that's equals to 75. Yes, this requires practice, but this is the logic. Prime factorization is going to help you basically to figure out the factors of the number and also see the number in a different way. Notice that here, if I have 5 squared times 3, then it's easy for me to figure out that the prime factors of 75 are 5 and 3. Let's do another example. Now, if they ask you what are the multiples of 75, then I will start doing 75 is the first one. Then I will do 75 times 2, which is 150. Then I will do 75 times 3, which is 225. So as you can see, when they ask you for the multiples, you're going to have infinitive amount of multiples, but you're going to have just only some factors for a number. So the multiples, they can ask you, find the first 7 multiples of 75. Find the first 3 multiples of 75. So for example, these are the first 3 multiples of the number 75. Now let's do more prime factorization, and let's identify again the factors of a number. So let's say that we have now the number 160. Let's break down this number as much as we can. So 160 is the same as 16 times 10. Or I can write this down as, remember, you want to make them as small as you can, 2 to the 4th, or I can say that 2 times 2 times 2 times 2, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 10 is equals to 5 times 2. Now the prime factorization of 160 is going to be 1, 2, 3, 4, 5, 2 to the 5th times 5. Let's do then another prime factorization. And we're going to use prime factorization to then learn the least common multiple and the greatest common factor, which is coming. Let's say that we have the number, let's just make up, another number. Let's make 111. We talk about this number. let's figure out what are the factors of this number. Now, 111, I look at it and I'm like, okay, for sure it's divisible by 1. And it looks like a prime number. So I'm going to go ahead and do 1, 1, 1, which is 3. So I can see that the number is divisible by 3. So I just do 111 divided by 3 is equals to 37. So the factors of 111 are going to be 1, 3, and 37. The prime factorization of 111 is going to be 3 times 37. Let's do another example. So let's say we have the number 42. So let's do a couple of them and let's try to do them as fast as you can. I don't want you to rush on this, but what I want you to do is that once you practice enough, try to see how fast you can do this prime factorization correctly. So I'll do 42. Let's say, what is the prime factorization of 42? Well, I can say that this is the same as 6 times 7. 6 is equals to 3 times 2, and then 7 is just 7. So the prime factorization of 42 is just 3, 2, and 7. I can also say that the factors of 42 are going to be 1, 2, 3, 7, and then I can actually figure out the combinations between them. 3 times 2 is 6, 3 times 7 is 21. Then I can do 2 times 7, which is 14. And you go and so on. And then I guess after here, it should just be 42. Now, finding factors, I'm not going to lie to you, it's very tedious. But once you get used to it, you can manage to do these questions. All right. From here, let's just do one last prime factorization. And let's say that you have, let's just put a bigger, like a typical number. So for example, 225. Now, the first thing I want to do is divide 225, into like two numbers. So I'm going to just say that this is 5 times 45. And then easily I can see that this is 5. And 45 is 5 times 9. However, 9 can also be written as 3 squared. Beautiful. The prime factorization of 225 is 5 squared times 3 squared, and that's it. After this video, we're going to learn how to find the least common multiple and the greatest common factor. So stay around.